Hi students, I am Dr. Badrinath and this video we will see the types of data distribution. Bell distribution, bell, temple bell, church bell, school bell, whatever it may be, bell distribution, right? And this is the image of the massive structure from Tamil Nadu, that is Madurai Meenakshi, Ammavaru, Madurai Meenakshi temple, okay? And this is my third video in the data distribution. In first video, second video, you watch it. Okay, later you come to that, then only you can understand well. And however, in this slide, I am focusing only on the bell distribution only, right? Okay. Types of data distribution is also called as types of probability distribution or probability variable distribution, whatever it may be, all are same only. In the examination, don't get confusion. Okay, they might give as a name different names, right? Yeah, we'll start. This is your syllabus for a Pharma.D, not only for Pharma.D, for everybody the same. This is the syllabus as per Pharmacy Council of India. Even though this is for Pharma.D, the same syllabus was there for B.Pharmacy and M.Pharmacy for pre-PhD also. So the highlighted point where here the types of data distribution. So that is our today's video number 3. This slide I have already explained you. Data distribution types: discrete, continuous, Bernoulli binomial completed in the first video, Poisson's distribution completed in the second video. These two are very important. These three are very important. Bernoulli, binomial, Poisson's, very important. And here normal, bell shape. Normal distribution is also called as a bell distribution. So what we are focusing this is today's this only. This is also very widely used and this is also important. So only 4 are important among the 7. Total here 4 and here 3. Total 7 is there. Among the 7, 4 are important. Bernoulli, binomial, Poisson's and normal. Normal is very important among the all. Bell distribution or bell shape. Very widely used. Very widely used. Okay. And this comes under the continuous probability distribution. And your curve will be like this. See here how the curve will be, just like a hill. Your curve will be not like this. Okay. Yeah. Bell distribution is also called as normal distribution. And if you he is the discovery of the is the hero, the Moivre is a doctor. He's a doctorate from France also. France is a French. Okay, Paris is the capital city of France. Eiffel Tower is there in the Paris. Okay, it is a world richest persons living in the Paris only, right? And if you see the definition, it is defined as the continuous frequency distribution. Just now I have told it comes under the continuous discrete distribution of the infinite range. Infinite indicated by the alpha, like that structure, infinite. The normal distribution is a descriptive model, not descriptive distribution. Okay, descriptive, not discrete, that describes the real world situations. Very important. This curve, how he designed, I don't know his thoughts. It fits into any situation, not only one. Really hats off to him, and he deserves the Nobel Prize for finding of this such a type of great distribution, temple bell distribution, real world situation, practically. Now we will see, this is the why we are calling it as a bell shape. See here, this is the curve. Like this, you will get a curve. Exactly, it looks like a temple bell. This is a bell-shaped distribution is the most common. And here, this bell-shaped distribution is he divided into 4 zones. 1, 2, 3, 4 zones. First one, center part is a zone 1. Not 1, 2, 3 seriously. Center, start from the center. This is the zone 1. What is the zone 1 value? 68.3%. It is a standard. It is a standard. No change, nothing. We cannot change it. It is already practically they did various experiments and observations. They concluded this 68.3% data. Right? It's a zone 1. Zone 2, besides the zone 1. See, this is also zone 2. This is also zone 2. 95.5% of the data. These values you have to keep in your mind. 68.3, 95.5% of data. Zone 3, you can see here, this one, you see my cursor, and also this zone, called as a zone 3. Now come to this is a 99.7% of the data will be covered by that. See, this is a zone 4. You will get it like this. 1. Like that you can divide. Center point is 1, besides 1, 2, besides 2, 3, besides 4. Okay, right. Now we will see the interesting and importance of the bell shape. Right? Now let's start. Bell shape distribution fits into any situation I have already told. Now you take the example of rich. See here, Mukesh Ambani comes here, whereas the poorest person here. This is the high end. Very Mukesh Ambani is the richest person. Rare piece is there. That's why here possibility is there, very less possibility is there. That's why here I have shown the height. See, height of the curve is go on increasing like this. Here mainly few members are there. 1 or 2 rare pieces are there. Richest. He is also world 6th to 7th. I think he became recently. Actually, he was in the 9th place or something, and he came to 6th place. Okay, rare piece, richest, and that's why curve of the height is very small height. Here see big height, middle class. All these are the middle class. Here the poorest class also very rare. Poorest persons who will die with the lack of food also possibility is there, but very rare. That's why here also curve shape is the. So these two persons comes in the zone 4. He is a poorest person, richest person. Most of them middle class, like you and me. Most of them. You might be more richest and all. See here, this is a middle class. 68 point in that you take this 68.3 not only in India, you take in the world, or you take in the Sri Lanka, or you take in the Nepal, whatever it may be, middle class peoples are more. 68.3%, you calculate, that's greatness of this curve. Yes, middle class. And you can see here, this is a middle class, is zone 1. This is the higher middle class. This is the lower middle class. This is the richest, very, very richest. So if you see the sequence, middle class, upper middle class, rich persons, very, very rich persons. If you come this side, middle class, lower middle class, poor persons, very, 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 very poor persons. Okay, so as per the data, middle class peoples are 68.3%, and if you see the upper middle class, 95.5%. You have to remove this 68.3. You have to remove from this 95.5 because middle class is there. So middle class as well as the upper middle class, if you clubbed both, 95.5% are there. And if you cover the rich and poor also, 99.7% are the rich, upper middle, lower middle, poor. If you cover the 100% is not possible. That's why we are not touching the curve here. Some gap is always there. Infinity gap. That I will explain you later. Like this is the fitness, not only richness. You take the beautiness. Examples of the beauty. See, Aishwarya Rai, rare piece, very rare, world's toppest beauty. Rare, very. See here, average beauty. Here you can see average, above average beauties. Very, it's a good looking and very high elegancy, beautiful ladies. Here, beautiful. Here, above average, beautiful. Here, highly beautiful ladies. And you can come here, below average ladies. Okay, and poor beauties, ugly, somewhat ugly, very, 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 very ugly beauty. Not only that, it's a God given. What we can do, you cannot do anything, and I cannot do anything. It's a God gift. That's it. It's a point of luck, purely luck. And what you did, this thing, that depends upon that another this one. However, like that, you can apply to anything. You can apply not only richness, not only beautiness. You see the talent, students marks. You take in your classroom example so that you can understand well. Average performers are about 68%. It is a common. Okay, see, these are the average persons. These are the high performance. These are the above average. These are the intelligents. These are the very, 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 very intelligents. I don't know in which, under which class you will come. This is average performance. Below average performance, poor students, very, 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 very poor performers. I like that. See how greatly designed the thing. Okay, it can be practically everywhere. You can found in the nature, in engineering and industrial processes, in social and human sciences, and many everyday data sets following approximately the normal distribution like this tests. Okay, like flowers, two good flowers, very beautiful and beautiful smell flowers are there, very rare. Most of the flowers are average and throughout the world. See, in the world also, you see the temperature, hottest, most of them are average only. Too cold is there. Too cold. In the, that is the poles, North Pole and South Pole are very too cold. When you are coming too hot, average are more, like that. And examples, the body temperature, too high body temperature persons are also less, too cold body temperature also very less. Average are the main. For healthy humans, heights, too height persons also there, very rare. Weights, weight to weight, sumos, Japan sumos, okay. Weights of adults, the thickness and dimensions of a product, uh, IQ and standardized test scores, quality control tests in the tablet production. Okay, most of them tablets are passes the test. Okay, they fits into the curve only. Two failure tablets are less, two good tablets also very less. Okay, errors in measurements. And if you come to the characteristics of this curve, the commonest and most useful continuous, it is a continuous distribution. It is a symmetrical probability distribution. Symmetry means, you know very well, if you cut the curve here, exactly this is opposite. You can see the mirror image. One half you can see in the mirror, another half. Exactly, it fits. That is called a symmetry. In the chemistry, there is a most of the molecules are symmetrical molecules. It is one of the wonderful concept. And another one is mean is equal to median is equal to mode. Center tendency of the data. Mean, median, mode, all are equal and all are present in that. And symmetry is exactly 50% here and 50% here. Symmetrical probability, and also its shape of a bell. It can entirely be described by the mean and standard deviation. 50% exactly matches to the total about the 50% mirror image. Very, very important. And this where you have cutting the points, two cuts I have shown. No, that cuts is called as a inflection points. You have to draw this diagram in the examination, bell shape, and a graphical representation of the normal distribution like this. Continuous data. It is determined by the mean and standard deviation. It is a symmetrical unimodal. It is also called as unimodal. Bell shape, all are synonyms only. Its tails extending infinitely, very, very important point. See, the tails never touch the x-axis, never touch. Even though you are extending also, fraction doesn't touches because that much possibility is also there, but very rare. It is the wider the curve, larger the standard deviation. See here, I will show you bell shape curve. This is a bell shape. This is also bell shape. This is also bell shape. Three bells are there. All are bells only. And if you come to the center point, mean, median, mode is all for same. For this curve, curve 1, curve 2, curve 3, same. But standard deviation is very less in curve 1 because almost all are same, looks like same. See here. And this here, somewhat variability is there in the pink color, second curve. Standard deviation is more. When you come to here, third curve, standard deviation is still more. Still, if you are widening the curve like this, widening the curve, standard deviation is increasing. That you have to keep in your mind. Variability starts. The wider the curve, larger the standard deviation, and the more variations exist in the process. The spread of the curve is equivalent to the 6 times of the standard deviation of the process. Spread, how widely data is distributed, is 6 times of the standard deviation. Yeah, helps in the calculating the probabilities for normally distribution population. Probabilities are presently rare under the normal. See here in this curve, you have to highlight the point, this blue color. 100% this we are considering. One side 50%, another side 50%. This 100% we are taking one also as a one also. Then 0.5 one side, 0.5 another side also. Okay. This total under comes under the population, entire population. Yeah, these points are important. I have told 68 percentage, 68.3 or 68.26. 68 is a point, comes under first category. Zone 2, 65 percentage, this much, and 99.7 third standard deviation of the mean. Within the one standard deviation of mean, two standard, three standard, I have already told up to 6 per standard deviations. Up to that, the curve will be extended. This is the formula. You have to by heart this. Z is equal to x minus mu divided by sigma. X is the data point. Okay, and Z here I have shown in the picture. What is the Z? Sigma is, you know very well, it is a standard deviation. Mu is equal to mean. Okay, Z is equal to our scores. All right. Yeah, power of a bell shape. There was a teacher in the university, and she gave assignments to the students like you and graded the students. She missed the entry of one student. Data, there is no data for the one student. Don't worry, bell shape will resolve. Yeah, here also same thing. You collected the 100 tablets, okay, from the punching machine, and you started measuring the something, whatever it may be. Okay, don't, if you have missed some data, one tablet data, you missed the hardness, no problem, don't worry. Bell shape will resolve. How the bell shape resolve? See, actually this is a continuous curve. Don't think that it is a column. For your understanding, I am showing here. This data you missed. The teacher didn't have the data of this student. No problem. For all the students, you can draw a curve like this, and you can automatically you can find the missed data. Here you can put the, she can put the point here, and he can find the what is the score here, scores with that, and she can give no problem at all, like that. This is the power of okay, bell shape. So here I have end my session. Thank you for Temple for, and also bell, where the bell is there, thank to all the bells. Okay, thank you. And in my playlist I have kept all my subjects. Okay, and you just go and watch, keep on watching.